So for our last example here in lesson 4.3, let's look at a word problem. So they were kind enough to give us this graph. This graph is always accurate for the problem, so that's kind of cool. So we are told a basic component of music is a pure note. The graph in figure 4, this figure right here, models the sinusoidal pressure Y equals P in pounds per square foot from a pure tone at time where X equals T in seconds. So what we're told is on the vertical axis, we are measuring pressure in pounds per square foot. And then x-axis is measuring time in seconds. So when you're looking at this, you can see the pressure doesn't even get all the way up and down to 0.006 or up to 0.006. And my time in seconds only goes out to 0.04. So they continued by telling us the frequency of a pure tone is often measured in hertz. 1 hertz is equal to 1 cycle per second. So if you complete 1 sine wave in a second, that is 1 hertz. So 2 sine waves in a second is 2 hertz. 3 sine waves, so forth and so on. So when you say 60 hertz, like we measure our electricity, what that means is when we're doing 60 hertz is we complete 60 sine waves in 1 second. Notice they said, I think yours said HX. Please notice that hertz is abbreviated big H, little z. So what is the frequency F in hertz of the pure tone on the graph? So what does this question want us to find? They want us to find frequency. Frequency is waves per second. That's what frequency is. It's how many waves I am going to make per second. So they want me to take this and convert the waves they gave me and in the time they gave me to how many waves am I going to make in 1 second. So I am going to set up a proportion that is going to compare waves and seconds to the waves I want and the number of seconds I want. So let's look at what they gave me. How many waves am I seeing on this graph? I'm going to count them. There's 1, 2, 3, 4, 5, 6 waves. This graph makes 6 waves. And it took us, those 6 waves were made in 0.04 seconds. We're asking ourselves, well, how many waves are we going to make in 1 second? So let's cross multiply. Since I have a fraction equaling a fraction, I'm going to cross multiply. 0.04x equals 6. 0.04x. Divide both sides by 0.04, so I'm going to get 6 over 0.04. So how many groups of 0.04 can I get out of 6? And that answer is 150. So what is my frequency? Our frequency is 150 hertz. Boom. That was easy enough. Question B is asking something similar but a little different. This says the time for the one to produce. The time for the one to produce 1 complete cycle is the period. Let's try this. The time to produce, there we go. The time to produce 1 complete cycle is the period. So approximate the period T in seconds of a pure tone. So they want us to find the period. The period is, they say, it's the time needed to complete 1 cycle. So what we are looking for is the number of seconds to make 1 wave. We are looking for the number of seconds to make 1 wave. So I'm going to compare seconds to the number of waves. Well, we already know that it took us 0.04 seconds to make 6 waves. We got that from the graph. I'm going to plug this into the calculator, and what the calculator tells me is it's going to come back and it's going to say 6.66666. It's going to give me a lot of the sixes, and then mine says e to the negative 0.3. When you see something like this, what this means is my number was either my value was too small or too big to all put on the screen. So what this says is, since it's negative, we're going to make this into a smaller value. Because this is a negative, we're making this number smaller. And we're going to move my decimal place this many places, my decimal point this many places left. So I'm going to take this decimal point and go 1, 2, 3, and I'm going to move it right there. So when I write my answer down, it's going to say point. Uh-oh, there's nothing there, so I'm going to add a 0. Nothing here, we're going to add a 0, and then we get the 6, and it goes on forever. So that is how many seconds it takes me to complete one wave. Now, if we're to put this into Canvas, we would say something like 0.0067 seconds. Get that rounding in. And then my last equation, this one is kind of cool. With my last example, they said, here's the equation that this equation was the wave we saw. This equation created that wave from the graph. So what we're going to do is we're going to use a calculator to estimate all the solutions that make y equal 0.004 over the interval 0 to 0.02. Alrighty. So when we graph this, I'm going to use Desmos. And here I've already got my graph up. I typed in the equation they gave me. And you can see, here's my sine wave. There it is. So the question asked, let's find all my solutions that are going to make y equal 0.004. So what I'm going to do is I'm going to come back into my calculator, and I'm going to add another equation to graph. Even if you're not using Desmos, any graphing calculator, any graphing utility will let you add multiple equations at once. So what this is going to allow me to make the line at y equals 0.004. And then you can use your calculator, however it is, to estimate these points at the top. So my x values are what I'm looking for. When is y at 0.004? When x is 0.00167. There's one of my answers. When x is at 0.00833. And when x is at 0.015. And I'm not doing this one because my problem said stop at 0.02. 0.02 happens right there. So those are the values we're going to put in, 0.00167. So my x values are going to be 0.00167, 0.00833, and 0.015. Awesome. Now, if you're doing significant figures, we're not going to do significant figures in this one. Alrighty, so if you've got any questions over anything, please let me know. I'd love to help you out, and I'll see you when I see you.